What if you could fire a projectile at 7 times the speed of sound, using nothing but pure electricity? This was the promise of the electromagnetic railgun, a weapon straight out of science fiction. In 2005, the US Navy embarked on an audacious quest, pouring over $500 million into developing this revolutionary cannon. It was designed to be the ultimate answer to a new generation of threats from global adversaries, a way to dominate the seas with overwhelming, low-cost firepower. The vision was twofold. Defensively, the railgun's incredible velocity offered a potential shield against hypersonic missiles, projectiles so fast that conventional defense systems are simply too slow to react. Offensively, it was a paradigm shift. Instead of multi-million-dollar missiles, a warship could fire a barrage of relatively inexpensive solid metal slugs. These weren't explosive. Their destructive power came from pure, unadulterated kinetic energy, hitting with pinpoint accuracy over 100 miles away. Imagine a gun that could fire at Mach 7, and because its projectiles were small and inert, a ship could carry hundreds, even thousands of them. It would be a nearly inexhaustible arsenal. This was supposed to be the weapon that ended missiles. Instead, it ended itself. Sounds unstoppable, right? Wrong. This is the story of the Navy's billion-dollar cannon that never fired a shot in combat. The journey began in the early 2000s, when the Office of Naval Research promised a revolution. The concept had been a staple of science fiction for decades, but with advances in material science and pulsed power technology, the Navy believed it could finally turn fiction into a terrifying reality. The core idea was elegantly simple, yet brutally powerful. Bypass chemical propellants entirely. It would use the raw force of electromagnetism, a principle known as the Lorentz force, to hurl a projectile down 2 parallel rails and achieve speeds previously thought impossible. The vision was breathtaking, a paradigm shift in naval power. A 32 megajoule cannon capable of hurling a projectile at over Mach 6, 10 rounds a minute, each one striking its target 100 miles away with the force of a freight train. And the cost? A mere fraction of a conventional missile. Instead of million-dollar interceptors, ships could carry hundreds of these inexpensive kinetic slugs, creating an almost impenetrable shield and an unstoppable long-range sword. This was the weapon that would make science fiction a reality, rendering entire arsenals obsolete. It was supposed to change warfare forever. But the universe has rules, and the Railgun project became a brutal $500 million lesson in what happens when a beautiful theory collides with the unforgiving laws of physics. The core problem was the sheer, raw violence of the launch itself. To achieve hypersonic speeds, the projectile is subjected to the Lorentz force, an electromagnetic push of unimaginable power. But this force wasn't just acting on the projectile, it was tearing the weapon apart from the inside. With each shot, a superheated plasma arc, hotter than the surface of the sun, would form between the rails, vaporizing and scouring away the conductive surfaces. The immense pressure and thermal shock would cause microscopic fractures in the barrel, which grew with every subsequent firing until catastrophic failure was inevitable. The Navy had built a weapon so powerful, it destroyed itself with every pull of the trigger. And then there was the power. The energy demands were simply astronomical. Firing a single 32 megajoule shot required a sudden massive pulse of electricity, enough to power a small town, all drawn and discharged in a fraction of a second. Integrating such a volatile power system onto a warship, a floating fortress already packed with sensitive electronics, was a monumental engineering challenge in itself. The ship's grid would need to be completely redesigned to handle these surges without blacking out or frying every system on board. So while the Railgun team wrestled with fundamental physics in the lab, their strategic justification was eroding in the real world. The weapon promised everything, but in the decade it struggled to even achieve reliability. Its potential adversaries weren't standing still. The world of military technology was sprinting ahead. A new generation of weapons was emerging, not from science fiction, but from the steady, relentless march of innovation. Advanced hypersonic glide vehicles, smarter cruise missiles, and networked munitions capable of precision strikes from 1,000 miles away. These systems were becoming operational realities. They offered the range, speed, and lethality the Railgun promised, but they were built on proven technologies and could be deployed far sooner. The strategic window for the Railgun was closing fast. Finally, in 2021, after more than 15 years of development and over $500 million spent, the Navy quietly shelved the project. The dream of the electromagnetic supergun was defeated not by an enemy, but by the relentless pace of progress. But the future didn't look like a railgun. It didn't arrive with a thunderous crack, but as a silent, searing beam of light. For centuries, naval power meant hurling bigger pieces of metal. The railgun was the ultimate expression of that philosophy. But the nature of warfare itself was changing, shifting from brute force to something far more elegant and far more deadly. The Navy had bet big on the railgun, but the strategic landscape was shifting. The new threats weren't just enemy fleets, they were swarms of cheap, expendable drones that could overwhelm a billion-dollar destroyer. Firing $1 million interceptor to destroy a $10,000 drone wasn't just inefficient, it was a losing economic strategy. A new solution was needed, one that could fundamentally change the cost-per-kill equation. The answer was directed energy. Lasers engage a target at the speed of light. There is no flight time, no need to lead the target. The moment it's fired, it hits. This instantaneous engagement is a revolutionary leap. The economics are just as radical. The cost per shot is measured in the price of fuel. As long as a ship has power, it has a bottomless magazine, an almost infinite supply of ammunition. This is the promise of the deep magazine, a warship that cannot be drained of its primary defensive weapon. The journey from lab to sea was methodical. In 2014, the Navy deployed the 30-kilowatt LAWS system aboard the USS Ponce, proving the concept. Then, in 2020, a major milestone. The USS Portland, with a much more powerful 150-kilowatt laser, executed the Navy's first hard kill of a drone at sea, burning it from the sky. This was proof that laser weapons had come of age, possessing the power to be truly destructive. The final step was integration. By 2022, the destroyer USS Preble sailed with Helios. This wasn't a bolt-on prototype. Helios was woven directly into the ship's legendary Aegis combat system, using the same sensors and tracking as the ship's missiles. It made the laser a seamless part of the vessel's defenses. It was the moment the laser transitioned from an experiment into a fully-fledged operational combat weapon. So what happened to the railgun? It didn't lose to physics, it lost to time. The project languished in the valley of death between prototype and fielded weapon. While the railgun team struggled with barrel erosion and power cycling, other technologies matured at a blistering pace. Hypersonic missiles redefined the offensive threat, while solid-state lasers became smaller, more powerful, and more reliable. The railgun was being built for a future that was already obsolete. The railgun program, after billions of dollars, delivered no operational weapons. But its true legacy is vital. Its immense electrical demands forced naval architects to rethink ship design, leading to the integrated power systems aboard ships like the Zumwalt-class destroyers, floating power plants. This infrastructure, designed for a weapon that never was, is now what makes deploying high-powered lasers and next-generation radars possible. The railgun was the catalyst that pushed the Navy into the electrical age, where power, not powder, defines the fight. Railguns dreamed of the future. Lasers made it real.